Hi, I'm Roland Worcester. I'm here to talk about the DisplayHDR Standard that VESA just announced at CES. To resolve the consumer confusion around HDR, where without numerical definition around HDR, you buy an HDR device, but you have absolutely no idea what performance level you're going to get with that device. At VESA, we wanted to build a standard, a three-tiered standard, that provides a very clear and easy to understand logo system that shows a DisplayHDR 400, 600, and 1000 performance level. What we've defined with this standard is a definition of white level, black level, which combined gives you a contrast ratio, bit depth, and color gamut. Also, the performance and the speed at which the display will respond from moving from black to white. Here at CES, we have manufacturers who have their first hardware developed to these new standards. So this is a standard that we launched back in December of 2017. It is published at the DisplayHDR.org website, and you can download all of the information for the standard. This is a fully open standard where you can get all of the information about how to test the standard, the purpose for each of the tests, even the mathematical models for how to build the test files. So if you are so inclined, you can build your own test routine. In the first quarter of this year, we expect to launch an automated tool where consumers, retailers, bloggers, reviewers can all download this tool and use that to help automate the testing procedure of validating a platform. So you'll be able to run this on a Windows platform, run the test images out to the display you're testing, and use a consumer-grade colorimeter to be able to inspect the display and check that it's performing as you would expect. From a certification perspective, we have much tighter criteria for the colorimeters that a factory or manufacturer would be using to achieve the certification level. We have details of those colorimeters on the website as well. At CES today, I'm very pleased to be exhibiting some of the first hardware that is likely to be certified for the DisplayHDR 400 standard. This model here from ASUS is a QHD 27-inch monitor targeting the 400 standard, and as you can see, is significantly better than a typical SDR display. This is the first level of our HDR standards. Behind me is the LG 32-inch DisplayHDR 600 targeted display. This takes advantage of local dimming so that you can get incredible black levels. It also increases the color gamut to 90% or at least 90% of DCI-P3. So you have incredible color gamut increase over your standard sRGB color that is typical of SDR displays.
Hi, my name is Jim Choate. I'm the Compliance Program Manager for VESA DisplayPort certification. Today I'd like to talk about DisplayPort DP8K cable certification requirements and DisplayPort DP8K displays. So here we have a Dell 8K 60 Hz display. One of the important pieces to know is it's not going to operate at the performance levels that you want if you don't have the right cable. So DisplayPort created a specific standard that's higher performance than existing DisplayPort cables have to meet today to ensure that when you connect your 8K display to a system capable of driving that display, that it will operate the way you want it to. So here we have a collection of various cables at different lengths, up to 3 meters, from different manufacturers that have all been certified with our new DP8K certification program. And each one of these cables is higher performance than existing DisplayPort cables to ensure that when you connect to an 8K capable display, that it will drive the resolution and refresh rates that you want for your higher performance system. And these are shipping in the market today, and we will continue to certify DisplayPort 8K capable cables as the industry demands higher performance cabling solutions for their high performance 8K capable monitors and PC systems. And we're at the VESA booth at the DisplayPort alternate mode over USB Type-C demo table. So here we are demonstrating an exciting development in DisplayPort solutions over the Type-C connector, showing a variety of solutions, not just including PC systems and displays, Mobile phones are the next big part of the ecosystem that's being enabled. So here we have a Galaxy Samsung phone with a Type-C connector that includes support for DisplayPort alt mode. You plug it into their docking station and it gives you USB ports, video, charging, and data to a full-size HDMI or DisplayPort display. Also included in this new collection of products that includes DP alt mode over Type-C support is the Nintendo Switch, which includes a base station unit that has a Type-C port, includes DisplayPort alternate mode over Type-C. One of the key reasons why products like these, like Type-C and DisplayPort, is it includes capabilities for charging, display, and data over one small form factor connector. You plug it into this docking station, which is connected to this display, and then you get a large display for your gaming or your phone or accessing your email. Not including, obviously for laptops, it's important to be able to connect to displays when you're in a working environment to have multiple displays. But for mobile products, it's critical to have a small connector that enables all these capabilities with one port, giving you charging, data, and display all in one.
Hi, my name is Alain Legault. I am Vice President of IP Product for Harden Incorporated in Montreal. I'm going to be talking to you today about the new technology that we developed for the DisplayPort 1.4 standard. In DisplayPort 1.4, there is now the capability to support the transport of display stream compressed standard. This is the block diagram of the demonstration that I will be showing you. It consists of the laptop and two FPGA boards that are representing the DisplayPort 1.4 transmitter and receiver and the display monitor. In DisplayPort 1.4, we're now capable to transport compressed video stream using the VESA DSC standard. That brings some new challenges. Over cables, such as DisplayPort, there's always some error of transmission. When we used to transfer uncompressed video, that was not such a big problem because occasionally if you have one bit in error, that would mean that one pixel would have the wrong color for 1/60th of a second, which is, nobody's gonna see this, very unlikely. Nowadays, with compressed video, the consequences are a lot more dramatic. So what we're seeing now is a display with some errors being transmitted. We see that some large rectangle flash on the screen, and these are the consequences of those transmission errors. Of course, having flashes like this on the screen is unacceptable. So if you plan to use the DSC compressed stream over DisplayPort, something else is needed. And this is why the DisplayPort 1.4 standard also incorporates a new algorithm called the forward error corrector. The forward error corrector, or FEC, allows to detect and correct those transmission errors that are causing the flash you see on the screen. The first FPGA board is the DisplayPort 1.4 transmitter that incorporates the DSC encoder and the FEC encoder. The output of this board gets to transmit information over the DP 1.4 cable to the second FPGA board, which is our DP 1.4 receiver that incorporates the FEC decoder and the DSC decoder. So let me show you what happened when we turn on the FEC. As you can see now, the monitors show a rock-solid display. So practically, instead to have an error like this that could occur as often as once every couple of minutes, the FEC that we included in DisplayPort 1.4 will ensure you of solid display year after year.
Happy New Year. I have good news. At the VESA, we have started development of the next generation of DisplayPort. This next generation of DisplayPort will at least double the data rate, enabling 10K, 4K progressive display at 120 Hz And then even with the DisplayPort alternate mode, it enables 10K, 4K, 60 Hertz, concurrent with USB super speed data and power. Stay tuned.